Okay, formulas of compounds. So we use formulas to describe compounds because we need a very concise way of communicating to each other what these different compounds are. So the compound, again, has atoms of 2 or more elements, and they're always in the same ratio, the same relative numbers. So the chemical formula tells us the types of atoms, atoms of which elements, and how many, the number of each type in a unit. So rules for writing formulas. We represent each atom by its element symbol. And then we indicate the number of each of them that are in a molecule using a subscript. There's that prefix sub again. Sub is below. A subscript is lower. A superscript is like Superman and it flies above. A superscript is raised, a subscript is lowered. And that subscript is written to the right of the symbol, so after the symbol. If we only have one atom of that element, we do not write the subscript 1. There's like a general pattern. It's an unwritten thing for chemists. Don't write the number 1 unless you absolutely have to. So I guess we figure, well, I wrote the C for carbon. If there were no carbons in there, I wouldn't write the C. I wrote the C, therefore there must be at least 1. I didn't write any other number, so you figure it out, there's only 1. Right? That kind of a deal. And you'll see it in lots of other things. So here's our example, SO3. So here's the element symbol for sulfur, and there's no subscript after it. That means there's 1 of them. Here's oxygen, and this has a subscript of 3. That means there's 3 oxygen atoms. So this molecule has 1 sulfur atom and 3 oxygen atoms, and that's what the formula is telling us. So the pesticide, known as DDT, paralyzes insects by binding to their nerve cells, leading to uncontrolled firing of the nerves. Sounds fun. Before most uses of DDT were banned in the U.S., many insects had developed a resistance to it. Okay, that's all background information. Do we need that? No. Backstory. Write out the formula for DDT. It contains 14 carbon atoms, 9 hydrogen atoms, and 5 atoms of chlorine. Okay, now we're getting somewhere. So we need symbols, don't we? What's the symbol for carbon? C. And how many carbons are there? 14. So we put a subscript over here. And then hydrogen has the symbol H, capital H. And there are 9 of those, so we put a 9. Oxygen is, there's no oxygen. That was a trick. Chlorine. What's the symbol for chlorine? Cl. Okay, I write my lowercase l's as a cursive or a script L because what's that? No, it's a capital I. What's this? That's the number 1. What's this one? No, that's the number 1 again. You can't tell, right? So this is capital I. If it might be confusing, then I'll make my 1 with, kind of fancy. The L, script L. Because the script L is a lowercase l. So chlorine, and has 5 atoms of chlorine, so a 5 here. So C14H9Cl5. So when you read a chemical formula, you just say the letters and you say the numbers just in order. Any questions?
Does it matter if you write the word with a capital letter?
No.
Notice that all of them have lowercase, but then the symbols are capitalized.
The symbols need to be capitalized. The words, you would use normal grammar conventions for the English language. If it starts the beginning of a sentence, you would capitalize it. If it's in the middle of a sentence, you don't capitalize it. It's not a proper noun.